Hello everyone, welcome to my channel Hypermesh Basic to Advanced. A quick background about my channel. I make videos regarding FE and Hypermesh. If you want to learn more about these topics, consider subscribing to my channel to get regular updates of the videos I post. Okay, so starting with the video, this video is going to be about inertia relief analysis in Hypermesh using Optistruct. So starting with the topic. So first of all, what is inertia relief analysis? So in inertia relief analysis, basically a body is analyzed under loading conditions, but with partial or no constraint condition. Okay. So what I mean to say is basically if you would have seen my previous videos, that what we generally do is we apply some load on the body and we also apply some constraints on the body, right? Whether it be this constraint on the degrees of freedom or constraint on the thermal side, whichever it may be. So basically, we apply loads and constraints both. But in inertia relief analysis, we only apply the loads and the constraints are applied partially or it's not at all applied, right? So the body is unconstrained basically. Okay. So what happens in this condition is when load is applied on the body, that is balanced by the body response forces, right? The body responds with the force and balances those. Okay, balances the applied force, right? So where is this analysis used? So this analysis particularly is used in flying bodies like aircrafts and satellites, right? So now coming on to the analysis part. So what I've done here is I have used a spring here. If you can see on my screen, I have a spring here, right? Okay, and I have meshed this spring with hex elements. If I can just zoom here and you can see these are hex elements, right? So I have meshed the spring with hex elements. Okay, it's a solid mesh, and I've applied a 800 Newton force on the top face of this spring element, right? So what I've done is basically I've created the spring element. You can see here the solid mesh is there, right? I've meshed it with solid elements, hex elements, right? After that, I've created material for this component, right? Spring component. So the material I've used here is steel. So this is the default material available in Hypermesh. Okay. So if you want to see this more details about this material, you can just visit my blog post where it's given in detail, right? So the material I've used here is steel. After that, the property I've used here is the solid property, right? Because it's a 3D mesh, a solid mesh, right? So the card image will be P solid. Okay. And I've applied both this property and material to the component. You can just see here under solid mesh, you can see under property it's solid property and the material is steel, right? So next I have created rigid elements. So I have created rigid elements is to apply the load, right? If you see here, this red color or maroon color, this is basically the RB2 elements which are created, and a master node is created where I have applied a force of 800 Newton in the y direction, as you can see here, right? Fine. So this is how it's done. Okay. So I have meshed the model, right? I have applied the material and properties, and I have applied the force through the RB2 elements, right? So just in case if you want to know how to apply the force, for that you can just go to the analysis here, if you can see, and then we can go to forces here, right? And then we have to select the node on which we want to apply the force, right? And we can just give the direction along which the force will be applied. Here I have selected y-axis, right? Okay, because we are applying in the y direction, right? And we'll give the magnitude here, right? So what we'll do is basically we'll just do one thing. We'll just update the force here. I've applied 800 Newton, if you can see. So we'll just update it to 200. in our case. Okay, so we'll just select this load. Okay, by load collector select. Okay, it's selected, and we'll just update its magnitude to 200 Newton. Right, this is now y-axis, and we'll just rotate it. We'll select magnitude, and we'll do update. Okay, so as you can see, it's changed to 200 here. Right, so we'll use this 200 Newton force here, right, along the y direction to perform the analysis. Right, so we have the mesh model, we have the property, we have material, and we have applied the load. Right, so next step will be creating the load step. So for that, we can just go into this white browser area, this area, and you can just right click and you can go to create and then load step. Right, I've already created a load step here. As you can see, it's named Inertia Relief. Right, we'll just select this, and under this, the analysis type will be linear static. Fine, and under the load field, we'll reference the load collector which is created for load. Right, so if you can see here, I've named the load collector load, and we are referencing it here under the load field. Right, so we have the mesh model, we have the material, we have the properties, we have the load created, and we have the load step created. Right? So just in case if you're imagining how to create materials and properties, for that the process is same. You can just go to this white browser area here, you can right click and go to create, and you can select material or you can select property, whichever you want to create. Right, so now we have everything ready. Well, there is some additional steps which are to be performed. Right, since we are not applying constraints and we are performing an inertia relief analysis, there are certain cards which we need to select. Right, so for that, you can just go to analysis here and you can go to control cards. Right, and then we have to go to parameters. Right, parameters. As you can see here, it's parameters here. Just go to parameters, and we have to select INREL. This basically means inertia relief. So under that, we have to select the value as -2. There are three values: 0, -1, and -2. We have to select -2. Right, so after this, we will also select global output request. So I've selected global output request for displacement, strain, and stress. If you want to extract any other output, you can select that as well. Right, so these cards are displayed here. If you can see under cards, we have parameter. Under parameter, we have, if you just scroll it down here, yeah, you can see here in rel. Right, for global output request, we have displacement here, and we have stress and strain here. Right, so basically, we have meshed the model, we have applied material and properties, we have created the load, and we have created a load step, and we have created the cards. Right, so next, what we can do is we can go to analysis and we can go to Optistruct. Right, so basically, we are using Optistruct here for performing this analysis. You can use any other solver if you want, like Nastran, Radios, any other solver if you want. Right, fine. So here we will select run options as analysis and export options as all. Fine, and then we'll just click on Optistruct. Right, to perform the analysis. Right, so once you click the Optistruct option, one dialog box like this will appear, right, as you can see here on the screen. So this is basically showing the progress of the run. So basically the job is completed now. So message for the job analysis completed, right? And this is how the Optistruct solver runs. So now we can go and view the results. For that, we can just go and click on results. And if you want to view the output file, you can just go to the drop down next to view and we can select output file, right? So for now, we'll just view the results. We'll just click on results. So once we click on results, window like this will open, right? So this is basically the hyperview interface where we do post analysis. Okay, so here I've selected the result type as displacement and magnitude, right? So I'll just click on apply, and this is how the displacements are through the screen, right? So if we can just see the animation here. We just click on play here. So you can see when the load is applied to the top face, where this is where the RB2 elements are there, how the spring is deforming and getting back into shape, right? So this is how it is there. So we can also see the stress and strain which we have taken as output, right? Here we can see the element stresses, right? And we'll just click on apply. Okay, so this is how the element stresses are there to the body, right? And we can just again click on play, and we can just see here, right? So if you want to see what is the maximum stress, we can just see it's given 685, right? So this is basically, this legend gives the stress values throughout the body, right? You can see it's somewhere near to this, right? And this blue area is somewhere here, right? So this is the stress plot, right? Same way if we see the displacement plot, right? So here it's the maximum one. If you can see, this part is coming down maximum, right? And the blue part is almost like constant, or it's almost not deforming or moving so much, right? So this is basically how you perform inertia relief analysis. Okay, so hope you liked this video, and hope you understood this and you got to learn something new. So if you like my videos and you are enjoying the content, if you are getting to learn something new, uh, I would ask you to consider subscribing, as these videos take a lot of effort and a lot of my time too. So thanks for watching my videos. You don't forget to follow my Facebook and Instagram page for regular updates and subscribe to my channel. Thank you.